So we're going to get started in just a minute. Welcome, everybody. Happy New Year. Excited to see you. See how we're going to use charge and AI for science. As you're joining, if you have any troubleshooting questions, we have my colleague Cam in the chat. He's just said hello. He's around. If you have questions about the session or you want to have a discussion, we're going to have some discussion time at the end. So you're welcome to post your questions in the chat. Cam will get back to you. We have an activity that is a little bit more in depth for the science classroom today. If you have a charge, you're welcome to follow along, but we also have examples that you can get access to at the end of the session if you want to watch for ideas today. All right, with that, I'm gonna get started. My name is Caitlyn. I'm the educational product designer here at Forward. And as I mentioned, Cam is here in the chat to support with questions as we're going along. We're going to explore AI literacy and science today. So we've got a cool new activity called Crash Test Engineers. But before we get started, I wanted to just give you a little bit of an overview if you're brand new to Create AI or to Forward. So as we're going along for the webinar today, we would love for you to post any questions you've got in the chat. We're recording this session, so don't worry, you'll be able to get access to it afterwards. We'd love for you to tag us in any social posts. We'd love to see what you're doing, either if you take this idea in your classroom or expand anything. And we also will have some polls or questions. So as we're going along, if a poll will pop up on Google Meets, it will display in the bottom corner of your display. And that helps to give us a better sense of like what your experience is. Do you want to see more of these ideas? So we'd love for you to participate in any way that you're comfortable. For those of you who are new to us, Forward Education was founded in early 2016. Since then, we've had the pleasure of helping over 500,000 students bring STEAM education to life. We've got a whole ecosystem of microbit kits and accessories that make it simple for new and experienced coders to get hands-on experience in the classroom. So today, I'm excited that we're going to use Charge. It's a simple, portable, rechargeable battery for the microbit, and it helps us get hands-on with different projects. So specifically, we're going to see what we can do with science, Charge, and Create AI. When we're thinking about AI, a lot of the time, AI can feel like a broad concept if you haven't taught the concept in the classroom, or if you're still getting into new topics related to AI. So when we're thinking about AI, it can feel like an overwhelming black box. It's not just chatbots or large language models. How you actually work with them and how you question the different pieces helps for both you as an educator, but also for students to have a more critical understanding. So the magic is in the model and working with those different pieces. We need critical thinking to train an AI model. So that's already embedded in curriculum concepts in your topics. So we can think about when we're working with a hands-on activity, if a model is biased, what kind of data could make it stronger, and how we can iterate on our work with engineering design principles as well. AI learning priorities with K-12 students. So there's tons of different priorities. There's lots of different state and national standards. This is just one of them from CSTA. So these are suggested topics for learning priorities for all K-12 students. CSTA is a national standard for computer science that can embed into curriculum. We're also going to talk about how science can connect to those pieces. A lot of the topics overlap. So it's the #1 priority to explore EdTech initiatives and understand more about AI. And 70% of educators believe that AI will significantly impact their teaching. Some of the topics when you're thinking about how to apply AI in the classroom is things like machine learning that we'll explore today. I'll move my head so you can see those topics. How society will actually be impacted by AI, and the design of ethical AI topics. So thinking about both how do we make AI work and how can we apply it in a meaningful way in the classroom. When we're thinking about science, a science standard for national recognition that we align to at Forward is the Next Generation Science Standards. And that is a topic that can easily connect to a state or local standard if that is something that you're looking for. And it's divided into broad categories with different applications for you. So some examples that we'll explore today is the physical sciences, and then a lot of topics that we have are related to engineering and technology. So we can break up those things and apply them into our classroom. So in the example today, we're going to explore how forces will apply to our actual microbit using the accelerometer, and how we can calculate motion acceleration and run different science experiments. Okay, for the main activity today, if you're going to run this in the classroom or follow along, you're going to need a microbit V2. That will give you access to Create AI and all of its capabilities. And you need some type of battery pack. It will help you for some portability. We recommend a microbit with a charge. That will give you really rugged portability. You don't worry about it falling apart. I would love to introduce Charge. It's a portable, wearable, AI-ready solution. It's a rechargeable battery pack that allows you to connect to anywhere. It also has little bricks on the back that you can use to attach to different projects if you have Lego or other Forward products. And you're able to connect it and take it wherever you're going to go. So today we're not using the wrist strap. It comes on and off for easy use, but it's a really accessibly priced, reusable battery. So I'll give you a bit of a demo in a moment for how we assemble the Charge if you have one for the first time. And we're going to also use Create AI. So Create AI is a machine learning program that we're going to use with Charge. Machine learning is a subfield of AI that gives computers the ability to make decisions without being explicitly programmed. So instead, they use data. When we were looking at those learning priorities a moment ago, machine learning is one of those subcategories. So it's a part of AI that we can use to make decisions with. Create AI trains a machine learning model using the microbit's built-in accelerometer. So the graph that we see on the screen is pretty similar to what we're going to explore in our activity. Today, we're going to explore how we're going to train an AI model to understand the difference in two different surfaces so that we can apply some concepts related to forces with our microbit. So when we look at different types of acceleration, we can use some of the standards or topics that you might already be teaching about in the science class. The activity that we have today is to apply Newton's third law, and we're going to design a solution to a problem that involves motion of colliding objects. That feels like really technical terms. This is an alternative in the classroom. If you were going to drop an egg and see how can I protect the egg from breaking, or run a crash test scenario, this is an engineering principle where you can have iterative design, and the microbit is going to collect that data for us. Okay, so let's take a moment. I'm going to show you how to connect your Charge for the first time, and that's what we're going to use with this activity. So we're going to take our screen. We're going to see Create AI. Okay, so I'm already connected to my computer, but what I'm going to do is just disconnect and show you how easy it is to use your microbit with the Charge. So I'm going to do a bit of a reverse here, and I'll show you how to connect for the first time. So the charge is a reusable battery pack. There's a charging cable that you can use to connect your computer on the side. So this is where we would charge our battery pack. And then we have a little switch on the side, and that's what gives our microbit power. So once you download your code, you can connect to your computer using Bluetooth or radio control. So you have more customization to be able to access your code. There is a little bit of a battery lead so that you can have easy management, and we're going to plug in our charge. So, and your microbit. So the first time that we attach our microbit, we're going to line up the corner of our microbit into the top of our charge here. We also see that there's a little bit of an extruded shape. That's going to line up on our microbit V2 with this shape in the middle of our microbit here. So I just line up one corner with the side of my charge, and then I'm going to gently push, and I'll hear a click, and I'll know it's in place. Okay, so that's connected. Compared to other types of rechargeable batteries you might use with the microbit, this isn't going to fly off anywhere. If you are using the wrist strap, that would connect into the bottom. Or if we wanted to extend and add the charge to get data with some other extendable building blocks. So the last thing I'm going to do is plug in my battery cable. So that's snugly in, and I can turn on the black switch, and I'll see some lights turn on my microbit. So that's how to plug in charge the first time. We're going to use it with Create AI and explore what we're going to actually do with the charge today. Okay, so we're ready to train our machine learning model. Our goals for today is we're going to go to createai.microbit.org. There is a link in the chat that you can go to and follow along. And then we're going to collect 3 samples of 3 different actions. So for this session today, we're learning about forces. So Newton's third law is that we have equal and opposite reactions on an action. We have different forces. So when we have a soft cushion, we'll have a little bit of a more gentle force that's absorbing, versus when a microbit or an egg or a crash test is going to be on a hard surface. It's going to be more of a significant force. So we're going to train those 3 actions, and then we'll see what we can actually do with the code. Okay, so let's go to Create AI for the first time. All right. As we go through, I'll show us on our microbit how to connect on the side window, and we'll see what type of actions I do with my different surfaces here. So on Create AI, the first time you go to the web page, we'll see this Get Started screen. So we're going to click on that icon. If you have a program like the one we're exploring today, you can upload that program and continue along with a saved session, or you can start a new session. Today, we're going to start a new session and explore with our code. So the first time that we connect our project, we're going to record some data samples. And what we see in the bottom of our screen is a little icon with a yellow flag. So that's going to tell us we have to talk to our computer. So let's click Connect, this bottom and the button in the bottom of the screen. And we're going to connect our microbit. So first, we've got our microbit V2. We're connected to our internet. We've got our USB port, and I have the cable connected to the internet. So I've got all of the things that I need here. I'm going to click on my Next button, and I'm going to have a little animation. So I've already plugged in my microbit to my device with my cable, but if a student was following along in a classroom, this is a helpful animation that can get them on the same page as you. So let's click Next, and we'll see a pop-up. So we're going to click on the device. I'll click on the Next button, and I say, Create AI wants to talk to our microbit. So I'll click on that device, and I will click Connect. Okay, so now I have a window. I've successfully connected my microbit. I can disconnect it, and we're going to connect one more time to our computer with Bluetooth, so it will be wireless. And that's going to let us, in this activity, make sure that our forces are recorded really well. So I'm going to unplug my device. My charge is still powered on. So I can see there's little icons displayed on my microbit itself. On the camera, the microbit LEDs flash a little bit. So what we're doing is we're making the same pattern. If I'm in a classroom with lots of students, those students are going to have different patterns. So it's pretty easy to just click on the little green box and match it. So in this case, my pattern is the same. I'm going to click next, and it's going to tell me to pair one more time. As you're going along, if you're following along, or if you have questions that you want to keep in your head for the future, you're welcome to ask any troubleshooting questions in the chat. Cam's available, or we can also chat at the end of the session. Okay, so we're in Create AI. We see this first window here, and there's a few different screens that we get to use with Create AI. So the first thing that we have with machine learning is something called data samples. And when we have an AI program, all of our AI make decisions off of large data sets. So essentially, the more samples of our accelerometer data, so it's like a snapshot in time of what's going on with the microbit. So the more we have, the more information our model will have to make a decision about an action. An action is a group. It's like a folder that will keep information about those different icons. So the first action that we're going to do is to have a falling action, or just kind of a rest. That will help our computer make a decision on our surfaces for our other two actions. So what we're going to do first is we'll pick a name. So this one we have is going to be resting. And it's just a name that we're going to remember our action by. I'm also going to pick an icon, or I'll remember which icon. So I can click on this little drop down, and I can pick whatever I like. I'm going to pick the heart for this. So each action needs to have at least 3 recording, or you can have as many as you want. But you can record many of them at the same time. So the more actions you have, the easier it is for your model to be more effective. So let's click on the record button, and I'm just going to, as I record, I'll get a countdown, and I'm going to move my microbit around while I'm resting. So I'm just gently going to move it. So we see this is one data set. If I zoom in on my browser here, we can see a little snapshot of that recording. So this is one little second, a moment in time of what our microbit was doing. With our resting for this activity, we want to make sure that all of our samples in our data set look similar. So we can record many actions at once, but we don't want to have really significant movements, so that will make sure our data is effective. I'm going to click on this little drop down. I'm going to record 10 seconds of samples and just gently move the microbit around as I do so. So that will make it really easy for us to collect lots of data samples. And I'm just going to gently move around in space as I record data samples. Okay, so we have our first action. It's just resting. And we can see we have 11 samples recorded. So we have our minimum of 3. Now what we can do is we can click this Add Action button. So the first thing that we want to do is we're going to test the difference of force on a soft object, a soft crash pad, and a hard crash pad to see what the difference is. So we can take a look at what's going to happen and make a prediction with our students. You can make this activity longer, or you can break it up into multiple classes. So for example, you could just take a look at what happens when I drop my microbit on the table with this little live data graph. So if I drop it, there's kind of a harsh icon there. We don't need to worry about the microbit or the charge breaking. It's pretty robust. So if you drop it from a short distance, I wouldn't suggest throwing it very hard at a wall, but we've got lots of different kind of options here. So we say, okay, what did that graph look like when it hit my hard surface? What does it look like when it hits a soft surface? So it doesn't jump around as much. So first, let's add an action, and we're going to have a soft crash. As a class, you can pick any types of materials and turn your project into a science experiment where you collect data on different materials. I have a face cloth of a pile of different cloths just bunched up into a Tupperware container, and it's acting as like a little pillow. So I'm going to get ready for my soft crash, and I'm just going to gently drop my microbit into my container here. I'm going to record at least 3 samples, and I'm going to pick up and drop it continuously. So we'll just click record for 10 seconds. So I'll hold it, I'll count down, and then I'll start my crash. We've got 10 crashes. Okay, so now what we want to do is take a look at what the graph looks like. When we're using Create AI, we're making decisions about data. So we had our data graph, and we know what it looks like when our microbit hits the actual table. We want to make sure that that is the same. So we can delete these non-similar graphs, and we've got a crash little icon there. So I'll just click the X button, and then we'll do our activity one more time with our code. We'll have a hard crash. As I drop our items on our table, I'm going to mute my microphone so that you don't hear all of the crashing on the table, and then I will unmute as soon as we're done. So I'm gonna get ready for my hard crash. I'm holding it about the same height, and we're gonna see what the difference is. I'm gonna record for 10 seconds. Okay, we had tons of crashes. So now we can take a look and just see how much bigger that data graph is. So any of the ones that would be like a data outlier, we could delete at that point, and as a group, we could have a discussion about something like that. So these look generally good to me. I'm gonna click this train model button so we can see what types of things we can do with that code. Okay, so once we have actions, in Create AI, you need at least 2 actions. So we have 3 in this case. We're doing extra work. We've got at least 3 data samples for each of those actions. So we're ready to train our model. This gives us an overview if it's the first time you've used Create AI. So our computer program will look at differences in the models. Create AI isn't taking any of the data, and it's not uploading it anywhere either. But we're just going to upload this data training model to our microbit. That'll help us make decisions. So we'll click train. And now we see a really zoomed in version of our model testing. So I'm going to zoom out just a little bit, and we can get a better overview of what that looks like. Okay, I've got all 3 of my actions. So this is a new dashboard that we see on Create AI. It's our testing model phase. And we can see that our object is green. It's some very similar actions. Our live data graph is still happening. And if I drop my microbit on the ground on a hard surface, it will probably show us our hard graph. And on a soft crash, it's going to show us our soft crash. So that little action will light up in the bottom and get highlighted here. So we'll try with our soft crash just for ease of use. So I'll drop it, and it goes immediately to that soft crash. At this point, if I'm testing as a group, then I would try looking at the difference between my hard crash and my soft crash. If they're getting confused, we can either edit our recognition point to say, I want to be more certain that I have a hard surface I'm crashing on, or less certain. Or I can go back and edit my data samples. So at this point, I'm pretty happy. We've got a hard crash, a soft crash here. We've got the low green and a hard crash. So it went right up. I think I'm ready to see what we can do with our code here. So let's click Edit in MakeCode. At this point, we're going to explore how to collect some data about acceleration in our MakeCode window. And we'll see, this is really familiar if you've used block coding programs before, or if you're an avid user of the microbit. It's the same window that we kind of have in the past. So when we use Create AI, we've just created a machine learning program with an extension here. So we can see that there is this machine learning extension. Create AI will start with the icons that you've programmed it and the words that you did. So if you said, if you had names here that were ambiguous, it might be hard to remember. That's why you want students to pick things they can remember. So what we're going to do is we want to see how many times we drop onto a soft surface and make a bit of a science experiment. So if we said, if I drop my microbit on a soft crash pad 10 times, how many times does my microbit detect that soft crash pad? And how many times does it detect out of 10 my hard surface? So what we can do is we're going to create a bit of an if-else statement, a conditional statement. So we'll have a basic code and this forever loop. I have some pre-programmed code that I'm going to open and show you. And I'll point out, just for the amount of time that we have, I'll point out the different areas that we have on our piece. So it's really easy to code with MakeCode and Create AI. Let's take a look at a code that I made earlier. So I'll say MakeCode. If I'm done with Create AI, I can download the program I made and I can keep it for later on my cloud projects. So as an educator, I usually keep my projects so that I can show students later. Students can just go to a link so they don't have to worry about any student logins if that's something that you're considering. Okay, so we see I've trained my model a little bit earlier and I've got some code here. So we've got all of our different pieces here. We say, if I am certain that my surface, my microbit is falling on a hard surface, I'm going to show my large icon and I'm going to count the number of times it fell on the table. When I'm done that, I need to know how many times it fell on the hard table. So I can press the A button on my microbit and we're going to see the number of times we landed on my soft crash pad and the number of times that my microbit lands on a hard surface that would probably get hurt. So if we download the code to our microbit, we can see how that works. So I'm just going to plug in my microbit to my computer and follow the steps one last time. So I'm clicking download, and then we've got our download window. Okay. So I have a heart icon on my microbit, and when I drop on my hard surface, I'm going to have a big icon that displays, and when I drop on my soft surface, I'll have a smaller icon that displays. For classroom use, I really like using the microbit display so that it's not overstimulating, but you could add sounds to this as well. When we're done testing our project, what we can do is we're going to push the button and see how many times it landed on the soft and how many times it landed on the hard. So I can unplug my microbit. I'm done with my code. I still have my power on. And what we're going to do is drop it on the table, let's say 5 times, and 5 times on our soft crash pad. Okay, that was 5. 5 more on my soft towel. 1, 2, 3, 4, 5. Okay, so then what we can do is we're going to chart that data. So we'll push the A button and we see a number. So I dropped my microbit 5 times on my soft towel, and the number 3 is displaying. So students can explore how many times my towel was effective. So in this case, if it has only 3, that means that either my towel was very hard on my poor microbit or my egg, or it was super duper effective. So it was an even softer landing. So we can tell by seeing how many times my microbit hit the hard table or a hard landing. So it says 7. So if I dropped my microbit 10 times total, we can see that my towel was a percentage of effectiveness at helping my microbit break the forces. So this is an example of looking at those 2 forces on my soft landing versus my hard table there. You can increase the complexity or explore more in depth, or you don't even have to explore this code if you wanted to just explore on MakeCode and create AI. So it's up to you what to do in the classroom. But this is a really exciting way of understanding and getting students started with forces and how AI can help us to interpret those forces. If you wanted to expand, there's a really cool project. You can start logging the data on your microbit and actually graph it. And then you can use that data to calculate the force based on the weight of your microbit. So your microbit can tell the amount of acceleration, and students can explore different types of activities in the classroom. So we have all different kinds of code. This code that we have as well has comments on it. So you can explore and iterate on your work as different students. So if I was going back to look at my code as a teacher, I could look at my comment here, and I see that this code increases if I am more than 80% certain that my landing is hard. I've got a hard table, then I'm going to add the number to my hard landing count. So that shows that I understand what my code is doing and how it relates to my project. Okay, so now that we've explored this activity with our forces and our crash testing, what you could do is ask students to design their own surface and see if you could either add a model or if their microbit can tell the difference between a third object. So what if there's something that has some hard rocks among our soft pom-poms, for example? And that's another activity you can explore. So let's go back on to explore what's next and see time for any questions if you want as well. So with this activity, like I mentioned, the next step that you could explore is a little bit more information with graphing and to calculate the amount of force that's being exerted on the microbit itself. So that can help you apply and go through different worksheet activities with students. This graph on the screen here is an example of the time that the microbit was connected, and how much force was on my project at the same time. So you can ask students questions like, what do you notice with the acceleration value on hard landing versus soft landing? So for example, we have our third soft landing on this little chart. We have less acceleration than our hard landing. So we've got, it's hitting the table at 1,223 versus 864. So you know how much help our towel is on our crash pad. So that's just one example. We'd love to know any other ideas for what you want to see next from our Create AI webinars. We've launched a poll in our in the bottom of your screen. So if you open the poll and respond, click submit. Any other ideas or questions you have, let us know in the chat so that we can help think of more cool ideas for what you can do in the classroom. Okay. Other than facilitating discussions about forces and motion, you can explore other AI tutorials and projects that the Forward Education team have published for free on our website. We also have teacher education courses if you wanted asynchronous resources to follow along and get more familiar and confident with Create AI. All of those projects are at learn.forwardedu.com, and they're available for free. We also love connecting Create AI with Forward Education's ecosystem. So if you have a charge or even just a microbit V2 and you're exploring some of these project ideas, you can extend the capabilities to connect to other Forward projects. So a really cool extension for this Forces and Motions project is to connect our charge with the little building blocks here using motors and add a crash test for a car. So we could look at how fast does the car smash into a wall and how much does the surfaces help our project there. So that's something that you could do to extend your exploration with Forces and Motions using projects or products like the Climate Action Kit with charge. We would love for you to stay connected with us. You can get in contact with us and let us know how your project went at hello@forwardedu.com. Our learning platform and main website are also linked. And we'd love for you as well to share any of your results with us, either online or on social media.